That's okay. So let's do 3, 4. Okay, this first one. We're going to perform the operation they want me to perform. So in this one, all they want is for me to add these. When they want me to add it, all I'm doing is combining like terms. So let me show you. I got an x squared right here. I'm looking for more x squareds. Yep, those are two I can combine. Let's go look for more. There's a negative 7x. I'm looking for more x's. Yep, that's the one. Yep, all that matters is that the variable situation match. So the variable and the exponent has to match. And then I see a plus 4, that's a constant. And I see a plus 2, that's a constant. And then this guy is all alone. Yeah. And then here's the other thing I like to do. Do you remember how standard form, it needs to go in descending order? Meaning, what we really want is biggest exponent first. Dot, 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 down to smallest exponent. Okay? Yes? Does that make sense? That's what descending order is.
We follow that every time we do this.
Yeah, that's what we want to do. So here's what I do in order to achieve all of that in one shot. I combine the like terms with the biggest exponent first. So that's my lonely 3x cubed. Do you see it? That's the biggest exponent. And then after that, I go to the x squared, which is the 2x squared minus the 5x squared. So that's 2 minus 5 is negative 3.
Wait, you do the 2x squared minus the 5x?
Yep.
Okay.
Yep. And then now I go from x squared to x. So that's my negative 7x minus 11x, negative 18x. And then I go to, after that, it's the constant. Constant means just a number by itself, no variable. That's the 4 plus 2. So it's plus 6. Boom, done. Okay?
And then
The next one. Oh yeah, totally. So this one's a little bit more complicated. Just a little, not a lot. It's a minus. All that minus does is force me to first change everybody's sign. That follow. Okay? So, for example, let me see. That 3x cubed was positive before. Well, now it's negative. The 5x squared was negative. Now it's positive. The 11x was negative. Now it's positive. And that was a positive 2. Now it's a negative 2. That's what the minus in the middle does.
Okay.
And then now you just go back to combining all the like terms, just like before.
What about, do we need to add, like, make it add the 7x and negative 4?
Yes, yeah. So see, now we go back to doing exactly what we did for number 1. I can combine the 2x squared.
Wait, but why don't you make 7 positives and 4 negative? If you did it to
No, the minus sign goes to everything that follows. Everything after it.
Okay.
Yep. Okay, so then I've got my x term. Oopsie. I didn't mean that.
Miss Lim, I could stay a little bit longer.
It's up to you.
Yeah.
I'll be here. There's this guy. And there's this guy. Everybody else, have a glorious evening. Thank you. Bye. Okay, so now here we go. Again, what I want to do is this in descending order. All right? So I'm going to start with the biggest term, the x cubed, and right now this time it's negative 3x cubed. And then I do the x squared. This time it's 2x squared plus 5x squared. So that's 7x squared. And bye, thank you. Thank you for restoring my faith. Here, this way, and then this way. And then the negative 7x plus 11x is 4x this time. And then 4 minus 2 is 2. So do you see how the minus sign really did make a difference? Everybody came out different. Yeah. Bye, you guys. Have a good evening. Okay. Cool.
Can we do?
Yeah.
Are we staying here?
Yeah, I'm okay to keep going. I have to make this video for you guys anyway. Might as well do it and answer your questions at the same time. Okay. Okay, let's see what they want. They want to figure out what polynomial was here that got added to that to become this. So it's all going to come down to the like terms. Okay? So like, for example, this negative 4x to the 5th, it became 8x to the 5th.
It became, or we like joined them?
It joined with something and became 8. So how does negative 4 become 8? The way I think of it in my head, I mean, you can subtract. You can say 8, take the second one, and subtract the first one. 8 minus negative 4. And minus minus becomes plus. So 8, so it's 12. So believe it or not, you had to add 12 to turn negative 4 into positive 8. Okay?
Oh wait, first, so I thought you meant like what do you have to add or subtract to negative 4x to the 5th to get 8x to the 5th?
Exactly. So negative 4x to the 5th plus 12x to the 5th becomes 8x to the 5th.
Okay.
And the way you can always calculate it is to take the second one and then subtract the first one. If you figure out what those two minus each other are, you're finding what adds to make it. Okay? So here's another way if it helps you see it. You want to go from negative 4 over to 8, right? So, hi.
Sorry.
Okay. All right. So now let's go see more terms. No? What am I doing? What did I just change to yellow? No, that needs to be blue. This one yellow. Okay. So now I've got an x to the 3rd. And then looking here, I noticed two things. One, that I have an x to the 3rd right there. And then that just made me aware that, holy moly, that x to the 4th term popped out of nowhere. Right? It wasn't in here. There was no x to the 4th here.
Yeah.
So this guy must have been here by himself. Negative 3x to the 4th.
Okay.
And nothing changed it because it was by itself. There was no other x to the 4th term.
You just add it. To
Yep.
Would
Just
you usually just put the negative 3x 4th like first?
see, because we like descending order from 5, an exponent of 5, we go to exponent of 4. Yeah. That's actually why I did that one first before I looked at the x cubed.
Yeah.
But do they say? They don't really specify here in the directions that they want you to have it in descending
But
order.
it's easier that way.
It's nicer.
Yeah.
Yeah, it's nicer. Yeah. Okay. It is a little hypocritical though, because when they want to trick you, they'll put the bigger degree term at the end, right? So that you don't see it.
Right.
However, then when it doesn't suit them, you better do it right. So, okay. Now let's keep going. I notice that there's this guy all alone, the negative 2x squared. So how did he get there? If there was nothing here for it to combine with, then he was exactly as he is right here.
But since it's descending order, wouldn't we do the 7x cubed?
Oh, shoot.
6?
Yeah, you're totally right. I forgot about the x cubed. I like highlighted it and then I forgot all about it. Yes, you're totally right. Okay, if I had 6x cubed, I added something and it became 7x cubed. What did I add? 6 plus what is 7?
That would be 1.
Just 1. So just a 1x cubed.
Oh wait, I'm like
It's you because they never asked you questions like this before.
Right.
So you look at it and you're like, this is new math that I don't know, but it's not that complicated what they're asking. It's just hard to tell. Yeah. That one is optional, by the way. You can just write x cubed. You don't have to put it. Okay, now our 2x squared. And then lastly, my negative 9 became 4. So, actually, so it looks, negative 9 became 4. So let's take 4 and subtract negative 9. I don't know why I wrote 6, but 9. You see how the minus, it screws it up.
Yeah.
Minus is plus. Actually, I had to add 13. Plus 13. And there we go. That's the one. Okay. All right.
Wait, so for the 4 minus 9, you just took. How did you get 2 subtraction? Well, I know the 9 was negative.
The 9 was negative. And then remember when we were looking at the 12, if you want to know something plus something, you have to subtract it. Exactly. Perfect. Okay, let's keep going. Oh man, are they being tricky. Right out of the gate, they're giving us a 13x to the 4th on the next one. They want it to become 15x to the 4th through subtraction. So let's do addition and then make it the opposite. What would you add to 13 to make 15? 2. So I need a 2x to the 4th.
And you did that because it's both positive?
Yeah, because 13 to 15, it's so easy to tell what adds to make it.
Yeah.
It's not so easy to tell what subtracts to make it.
Right.
However, the opposite, if you subtract the opposite, it's the same as adding. It's like a double negative situation. Oh, just like here. Remember when we did minus negative 9, so it became plus?
Yeah.
So if I want to add 2, I should do minus negative 2. Okay.
I kind of see that. It's
Yeah.
Like, but you said that it won't necessarily be on the test.
I don't know. I haven't looked at it, but yeah, this is kind of it's kind of a weird question. Like they're making things difficult that don't need to be difficult.
It's just like a little confusing.
I don't know. Yeah, it is a little weird, but to think, how did 13x to the 4th, what did I subtract from it for it to become 15x to the 4th? And so 13x to the 4th minus negative 2x to the 4th. Yes? Okay, good.
Yeah.
Okay.
I now get why you added the negative.
Perfect. Yeah. Okay, so then let's keep it going. I have a negative 5x cubed. And I want it to become 3x cubed. So again, it's easier for me to think of what I need to add and then switch the sign because subtraction's the opposite. So I gotta add 8. I have to add 8 to negative 5. Oof, this didn't go well. negative 5 plus 8 is 3. But because of this subtraction, I need to do the opposite so that minus becomes plus. And then my x squared right here became negative x squared. So that's like the same as subtracting 2. Right? Because x squared minus 2x squared is negative x squared. However, because of that minus sign there, I actually have to change that. So literally everything we're finding, we're changing the sign on it.
Right, and you put 2x squared because of the plus 2x?
Yeah, so it's because of this minus, the minus will turn my plus into a minus. And so x squared minus 2x squared will be negative x squared. And then I have a 2x here. There was no x term here at all. So I had to have a negative 2x here so that the negative would turn it into a positive. And lastly, I've got a 10 here that vanished, which means I must have subtracted a positive 10. 10 minus 10, and it went away.
Okay.
Anyway, that's that one. This is a weird question.
Number 3 I get, but 4 was iffy.
4 was very tricky, yeah. Basically, here's a good way to think about it. When you have a negative, remember earlier we did this, it changed all the signs that followed.
Yeah.
So you can just find all of this the normal way and then go change all the signs that follow
Got it.
to account for the negative that's here. Yeah. Okay. Man, this looks like a whole traffic light everywhere, traffic lights. Okay, so let's keep going. Number 5, write f of x as a sum using the fewest number of terms. Okay, this is all they mean is multiply and simplify. Multiply, simplify. Do you want me to use the box or do you want me to distribute? What do? Do you use the box? I think a lot of people look at the box and judge it, and then when they use it, they love it. So let's do the box. Okay, here's what you do. You take the x minus 3.
Multiply and simplify because it says sum, right? Sorry. I now see the x minus 3 times.
This is times, but you're right. That sum word here is confusing. Look what happens when we get a polynomial. Isn't it like the sum of a whole bunch of terms?
Yeah.
That's what it means.
Because I was like, sum, isn't that like addition?
It is, yeah.
And
That's
so-
the, totally. They want you to multiply, but they want your answer to be the sum of a bunch of terms, yeah. So here's what we'll do. We'll take x minus 3, and we'll put it along one side of the box. And then we'll take x squared minus 4x, and we'll put it along the other side of the box. And now what you're going to do is multiply the dimensions to get the areas inside the boxes. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. X times negative 4x, negative 4x squared. And negative 4x times negative 3 is positive 12x. This right here is my answer inside here. However, notice that you have this and this are like terms. So what we're going to do is we're going to write it, we're just going to combine the like terms as we write it. So my biggest exponent should go first. That's the x cubed. Yep. And then after that should be my x squared. But my x squared is negative 4x squared minus 3x squared, which is negative 7x squared. And then the last one is that 12x, so plus 12x. You see how it's the sum of a bunch of terms? That's what it meant. Yeah. And when it says fewest number of terms, it means combine the like terms. They don't want 4 terms. They want the like terms combined to give the fewest number of terms. That's what those directions mean.
If it said like a largest number of terms.
They won't say that. No.
Okay.
No.
So
This is them using cryptic language to say
okay.
simplify. Yeah. They just want you to
get everything right here for like the test.
You're doing great. You're doing really, really good. Okay, so let's look here. Next one. They want me to multiply and simplify. Again. So let's use the box. So we're going to have, the one with 2 terms has to go along the dimension with 2. So this time I have to go 2x squared minus 3x. And up top, I got to go x cubed plus 4x squared minus 5. And then I just start multiplying this times this. is negative 2x to the 5th power. So you multiply coefficients and you add exponents. This is negative 8x to the 4th power. This is 10x squared. So far, so good?
Yes.
Yeah. And then this is negative 3x times x cubed. That's negative 3x to the 4th now. Negative 3x times 4x squared. That's negative 12x to the 3rd. Negative 3x times negative 5 is 15x. And now I look for like terms that I can combine. I see just perfect. Perfect. They're the only ones. Nobody else has the same exponent going on. And then now I'm going to combine as I write them from biggest exponent down. So the biggest exponent is at negative 2x to the 5th. Then it's the x to the 4th, which is negative 3 minus 8. So it's negative 11. And then I go to the x to the 3rd term. Then x squared. And then 15x. It's descending order. It's all the like terms combined. It's beautiful. It's ginormous, but it's beautiful. Okay? Random little spiral review here. The degree of this guy is 5. And the lead coefficient is negative. It's negative 2. So the odd degree and the negative means this guy's graph actually looks something like that. Okay, it starts and ends in opposite directions, and it ends up going down at the end because it's negative. So this was just a little review of end behavior. Okay, now we have 3 things to multiply. And in any time we have 3 things to multiply, we multiply 2 of them first, and then we multiply by the 3rd one. Right? Like if you had 5 times 2 times 7. You can't multiply all 3 all at the same time. So you would say, okay, what's 5 times 2? That's 10. And then what's 10 times 7? Yeah. So that's what we're going to do. We're going to say, what's this times this? Simplify it, get what it is, and then multiply what we got by the next one. Okay? So we could do the box. Do you want to also see the distributing way? Or do you want to stick with the box? Okay, no worries.
Kind of like easy.
I do agree, yeah. When I first saw the box, I was like, who's gonna go draw a box?
Yeah.
But then when I did it, I was like, this box is nice.
Yeah.
Like
when my friends explained the box method, the distributing, I was like completely lost because like you have to do one here, one there.
Yeah.
But the box is like organized.
Yeah.
And simple.
It is super organized. Like it's so like, it actually I think saves time.
Yeah.
So it's pretty good. Yeah, x plus 5, and then we have x minus 8. And then we just start multiplying. So x times x.
We just don't include x minus 11.
Not yet. So we're kind of in the stage where we're multiplying 5 times 2.
Got it.
That's what we're doing. We're just multiplying the first 2. And then back like in elementary school, you couldn't do 5 times 2, so you'd have to draw 5 boxes 2 times to see what, right? That's kind of what we're doing right now. We're working out what 5 times 2 is
Okay, so
with the box.
X squared,
Beautiful.
and then x times 5, right?
Yep.
5x.
Beautiful. Then negative 8 times x, and then negative 8 times 5. And then I get my like terms again. So this becomes, where should we write it? Let's write it above it. This x plus 5, x minus 8, it becomes x squared minus 3x minus 40. And now you multiply it by x minus 11. Now we are doing the last one. So now this is 3 terms by 2 terms. So we need a 3 by 2 box. So we've got our x squared, our minus 3x, our minus 40, And then we have our x and our negative 11. Oh my gosh. I hope this is the first time I've been writing stuff that's not in the video. Okay. And now we just go x times x squared, x cubed, x times negative 3x, negative 3x squared, x times negative 40, negative 40x, x squared times negative 11, negative 11 times negative 3, positive 33x, and negative 11 times negative 40 is positive 440. And now let's look for like terms. Oh, we got a couple of them. We got those guys. And those guys. So, starting with my biggest, that's the x cubed. Then going to the x squared, so negative 11 minus 3 is negative 14. 33 minus 40 is negative 7. It ends with that 440. Final answer.
Where you just also placed in the 3 by 2 box, you placed the x squared and negative 3x in there, right?
Yeah.
And
So
okay, that's where all those.
that's where it came from. So because I noticed that there's 3 terms here, I knew I had to have 3 going somewhere. So I made a 3. You could have done it the other way too. I just stuck to the way they drew the 3 by 2 box last time. Yeah. But you could have made it vertical. Like you could have gone this way. It would have been the same. Okay. That's that page. I didn't take a picture of the next page. What's on the next page? Let's see.
It's just 3 questions.
Let's see if it's worth taking a picture or if I can just do it. So page 172 has some more stuff. Yes, okay. There's no, I don't need to take a picture of this to show it to you. So on the next page, on page 172, it gives me, let me write it for my people who are scrolling through the video. On page 172, it gives me h of x equals x minus 4 times negative 2x squared minus 3x plus 6. And it just wants to know what kind of function it is. So if I'm multiplying, I'm totally okay to make the box, make a 3 by 2 box and multiply it out like we did this one.
Okay.
That's totally fine. However, they didn't ask for the whole polynomial, and I don't need the whole polynomial. If I want to know what kind of function it is, all I need to know is the degree.
So that's that negative 2x squared.
Oh, it looks like it, but when we're multiplying, when there's an operation happening, we cannot trust it.
Okay.
So here's what I would say.
But if you're adding and subtracting, it's different.
I would still not trust it. Because remember the example we did in class where our biggest term canceled out and it went away?
Yeah.
There was like a 2x cubed minus 2x cubed, and then I didn't end up having an x cubed, and it became a degree 2 polynomial. So never trust it when operations are happening. Investigate, all right? The biggest term is gonna give me the degree. That's the key, the biggest term. And my biggest term is going to come from me multiplying the biggest term in the first polynomial by the biggest term of the second polynomial. Like I'm never gonna get anything bigger than when I multiply x by the negative 2x squared.
Okay.
If that makes sense. If it doesn't make sense, you guys, please just make the box.
Yeah, can we
Just make the box.
Yeah.
I don't want to multiply the whole thing out because I don't want to do
Okay.
too
so
much.
To make the box, you just put negative 2x squared.
Yes.
Negative 3 and then 6. And
Yep.
Then
Yep.
x minus 4.
And then you multiply them.
Okay.
And you see what the biggest term is. But you'll see when you do this that the biggest term will come from multiplying this biggest term by that biggest term to get the negative 2x cubed. Nothing else will get as big as that. So the degree will come from negative 2x cubed, and so the degree will be 3. Yeah, I don't want to do it because I don't want you guys too dependent on me doing it. We did a couple examples of us doing this. So now if you want to do it, try and see if it works. Because if you don't try on your own, you will get stuck on the test. That's how it goes. Okay, so the degree is 3. And degree 3 polynomials have a name. They're called cubic. So that's what the answer is in number 8. Number 8 is a cubic polynomial. And then looking at this,
And we just take the degree, right? Does it want the coefficient?
it doesn't yet, but in number 9 it does. Okay, in number 9 it does. In number 9 it wants me to figure out the end behavior as x approaches negative infinity, meaning on the left side h of x is approaching what? As x approaches positive infinity, which means on the right side, h of x is approaching what? So looking at this term, I notice that it is negative and odd.
So they're both going to become like
Opposite ways?
Going down.
Exactly. Boom. That's our guy. That means on the left side, I'm going up, so infinity. And on the right side, I'm going down, so negative infinity. Okay, and then I'm gonna stop here. I'm not gonna do number 10. You really want me to do number 10? I will. Let's do it, whatever.
Okay.
Let's do it. Do you want to do it or you don't want to do it?
No, I want to do it, but if you don't want to do it, it's
No, don't worry about me. It's just that these questions, they're fun,
okay.
but there's like never a test question like them. So I don't know how many people get into this.
Oh, this is like awkward.
It's annoying. I mean, at least I think it's going to be annoying. Let's see. So I want something x squared minus something times something x squared plus something to become this. And I can only use, any positive integers. They don't put like the 0 to 9 restriction on me. Okay, well, this might be easier than I thought. I thought it was going to be 0 to 9. Look, if I have two, if I go in the box, if we're going to do the box, and I have like something x squared here. So this is a something, not a negative. And then I have negative something here. And then I have something x squared here. And then a positive something here. When I multiply them, the x to the fourth, the 12x to the fourth is here. The negative 15 will come up here. And then here I'll get two things that when I combine like terms become this. So knowing that, I know that only way I'm getting a 12 is if this is like a 1 and a 12, or a 2 and a 6, or a 4 and a 3. Basically, I'm just going to pick two numbers that multiply to make 12. Now, it might end up biting me in the butt later, but I'm never going to be able to figure all of this out in my head at one time.
Okay.
So you start somewhere.
Times 2.
You want to do 6 and 2? Good. Okay, let's put 6 there and let's put 2 there. So with the 6 there and the 2 there, let me write them. We put the 6 here and we put the 2 here. We multiply them, we get 12x to the fourth. Fantastic. Then I would multiply the 2x squared by whatever's here. So what number do you want? Let's just put something.
That equals what?
I don't know.
Oh, okay. 2 and
Actually, no, wait. I do know. I know a little more than I thought I knew. Look, these two numbers, this box and this box, need to multiply to make 15. So 1 and 15 or 3 and 5 is the only way. What do you want? Let's do 3 and 5, okay. So I'll just put 3 in this one and 5 in this one. So keeping with it, 3 is here and 5 is here. So now let's go see what this becomes, because now I can multiply. So I would do 3 times 2x squared would get me 6x squared. And then over here, 6x squared times 5 would get me, oh shoot, this is negative, my bad. That 3 was negative, so it should have been negative 6x squared. And then 6x squared times 5 is 30x squared. And then my like terms here, we're gonna run into a problem right now, but it's an easily fixable problem, so don't worry. Look, my like terms are 30x squared minus 6x squared. That's 24x squared. But look at this. Look at that negative they put right there. They wanted that to come out negative. That means, see how that 6 was negative, but it wasn't strong enough? Yeah. That means I should change my 5 and 3. I should put the stronger negative number here. Does that make sense?
So the third, which one you're gonna put?
So 3 times 5 is 15 no matter what, right? I just made the 3 negative and the 5 positive and it didn't work out. Let's switch it. Let's make the 5 negative and the 3 positive. That would still get me the negative 15, okay? But then here's the problem. It helps a little, but not all the way, because the other reason that this 30 was so big and it turned my negative 6 positive was also because it had a 6 right there and this guy only had a 2. So I would also switch the 6 and the 2. I'd put the 2 here and the 6 here. So I still have 12x to the 4th. So those two didn't change. But now these boxes change. Now 6x squared times negative 5, there's my negative 30. And then 2x squared times 3, there's my 6x. And so now when I add them, I get negative 24x, which means I can just put 24 right here and I'm good. Now there's lots of different answers. Like if we had done 12 and 1 or 3 and 4, there's so many different possibilities. This is not the only right answer, but it's a right answer. Yeah.